Welcome to another episode of Dev Lantern. It's your girl again, Chazi. Today, we'll discuss how to build a robust and successful server-side application. They say experience is the best teacher, which is why I'm thrilled to have Chukwuma with me. He's a senior backend developer, and he's going to share and discuss with us how to make our microservices resilient. Welcome, Chukwuma.
Thank you.
It's good to have you.
Thank you.
So I learned yesterday was your birthday.
Yeah, something like that.
So don't tell me you worked all through yesterday.
Well, I didn't have a choice.
Really?
Yeah, we don't get off days for birthday. Work has to be done. So yeah.
All right. So how long have you been in the tech space?
Almost 6 years now.
Wow. How has it been?
Well, has its ups and downs.
Okay.
Its good moments and its bad moments, but in general, I enjoy what I do. So.
All right.
Yeah.
Have you ever had the thought of stopping or diving away?
Well, not really stopping, maybe transitioning into other aspects of tech, but still within the tech ecosystem.
All right, that's nice. So first off, before we can say, okay, let's pick microservices or let's pick monolithic, I mean, the architecture for an application, how do we decide which one is the best for our .NET application?
Well, I think it depends on the scale of what you're doing.
Okay.
So usually for smaller applications, let's say you're designing a to-do app,
Okay.
it wouldn't make sense to use microservice because microservices are costly to implement. Yeah, but if you are designing something that needs to be fault tolerant, it's going to be used by a number of users, has different moving parts, then microservices might be a good option for you.
What do you mean by different moving parts?
Yeah, so let's say you are building a hotel booking service that's also integrated to, let's say, flight booking. So an application that helps you plan your travel, tourism, and stuff like that. So it would have hotel booking, it would have cab booking, it would have plane bookings and stuff. So those are different moving parts. It will have payments, and it has a lot of logic. Right, and these things have to be, refactored and abstracted out into different services that will now make each of them a microservice.
Okay, nice. I'm sure you have some stuff for us to learn today. Can you show us?
Well, so today we're basically just talking about how we're designing resilient microservices.
Sure.
We'll be focusing more on a library in .NET that is called Poly, that we can use to make our services more resilient. So things like retrying a service or retrying an API call when it fails, things like introducing a circuit breaker or a timeout if the service is taking too long to respond.
Okay. So you know how frustrating it is when you're using an application and it starts lagging. And to make it even worse, when a problem or an error from one service affects other services or the whole application from working. Now that we can say that's like a monolithic architecture, right?
Yeah.
Now, which is where microservice comes in. So now with your level of experience and the number of years, right? How have you been able to solve this problem using microservices architecture? I mean, what are the design you've implemented to make sure that your microservice is resilient from failure?
Yeah.
Could you please tell us?
Yeah, so that's a good question.
Yeah.
So usually when a failure happens and affects other parts of the application, it's because the application has like a single point of failure. So for example, there is a failure on the database, it could affect the whole application because the database is not reachable. And that's why we could have microservices with each microservice using their own database so that if there's a failure somewhere, it doesn't affect the rest of the system. We could also have redundancy in the sense that a service could have different nodes. So if a node is down, then the load balancer could actually route requests to other nodes that are up. And then we could have things like retrying, automatic retries, and then timeout if it's taking too long to respond. So all these measures put in place would prevent having a single point of failure or having errors propagate to other parts of the application. So
you mentioned load balancing. So how does that work? Like, how do we implement that?
Yeah, load balancer is just basically a server or a proxy that directs traffic to different instances of your application. So let's say you have your backend service. It could have like 5 instances. And then it routes requests to those 5 instances so that one instance is not overloaded.
Automatically?
Yes, it does that automatically. It's not overloaded with so many requests.
All right.
And then if one instance is down, then it wouldn't route to that one. It will route to the other ones that are up.
Okay. Just like you mentioned, you said microservice is more costly.
Yes.
Now, if an application has different databases,
yes.
You know how SQL Server is really, really expensive. Like,
yeah.
So now they have to pay for all the database.
Yes.
So is there no other way around that?
Well, so that's one of the trade-offs that you have to deal with in microservices. It's costlier because you use more resources. Yeah, but you also have the benefits of having single points of failure. So it depends on the kind of application you are building. So you have to weigh the cost and the benefits. If the benefits outweigh the costs, then you would go for it.
All right. So can I say, I have a monolithic application, and probably when I was building the application, I really did not have some features. So now I want to transition to microservices. Is it advisable?
Yeah, so that's a good question. So and I think the first step is to analyze the application and see whether going the microservice route suits your particular use case. And if at the end of the day you've determined that it suits your use case, then there are measures you could take to migrate your application to a microservice. So it wouldn't really be a good idea to just build microservices and then just route all requests directly at once. That could cause some errors. So what people would do is that they would abstract or refactor out modules. So let's say you have a payment module, you might want to refactor that one out as a microservice. And then when users want to pay you, gradually direct traffic from your monolith to your microservice. And then in that case, you can monitor how it happens. You can monitor the errors. You can monitor the logs, see whether there's anything that needs to be fixed. And then you're able to fix it, direct more traffic, just gradually, incrementally, until you now finally direct all traffic from your monolith service to your microservice. Then you move on to the next module that you want to refactor out. So cool. It's an incremental and a gradual thing.
Okay, not like you just transition the whole thing at once. All right. So now, the practical example, can you show us how to make sure that our microservices are resilient to failure? Can you show us the practical example now?
Yeah. So here I made use of Microsoft HTTP Poly, which is a library that is available in the .NET environment.
So it's inbuilt?
No, it's not inbuilt. It's a NuGet package that you have to install. And from here you can see that Poly is a .NET library that can provide resilience and fault tolerance. So there are a few features of Poly. One of it is retries. So if you want to retry a service, you get an error response, you want to retry it a couple of times. Poly provides that. You could also have circuit breakers. So circuit breaker is when you notice that a service is failing, and rather than continue to direct traffic there and it keeps on failing, you open the circuit. So it's just like in electrical wiring. When the circuit is open, electricity can't flow. When the circuit is closed, electricity flows all around. So you open the circuit and then any other request coming in doesn't even need to get to the service because it already knows that it would fail. So it just stops it. It just fails any other request that is coming to give time for the service to come back up and not to overload that service. So that's...
Sorry to cut you.
Yeah.
So all of this, are they going to be automated?
Yes. So Poly just basically gives you a very quick way rather than writing your own implementation for everything. Like they say, don't reinvent the wheel.
Well, that's amazing.
Yeah. So, and then...
You can go ahead.
Okay, thank you.
Yeah.
And then you also have timeouts. So you could have timeout where you want to fail a request if the service doesn't respond within a particular amount of time. And then you could also have jitters. Jitter is basically retrying your request, but at randomized time intervals. So usually we have a concept of exponential time. So you try a request once, it fails. You try it 5 seconds later, if it fails, then you can try it like maybe 10 seconds, then 20, in an exponential way, like that. But what jitter does is that due to some disadvantages of that exponential way, where if there are many services trying at that exponential rate, they would also still almost overload the system because each of them are trying almost at the same time.
Okay.
Yeah. So jitter kind of makes it randomized, right? You can try in 5 seconds. The next one can be 5.2. Then the next one can be 5.8. Then, yeah. So it just randomizes it so that it gives time for the service to respond.
So what if the service did not respond?
Yeah, so there's also set configurations that, okay, it doesn't respond after a certain number of retries,
right.
Then you just fail.
And, more like a validation to check that, right?
Yeah.
All right, please go ahead.
Okay, so so what I will do now is that I would show code implementation on how a poly is implemented.
Cool.
Yeah, so I've talked about the key features. Okay, so we have here some code that shows how HTTP requests will be made. Here we have the HTTP client factory. We have the retries, we have the retry delay. This retry delay is in order to show how to delay between retries. So you have to give it some time before you retry. And without using poly, what you have here is you can see here is making a request.
Yeah,
it checks if the status code is internal server error, if it times out, and the retry count is less than the maximum amount of retries.
Yeah.
If that's the case, then it retries it. But if that's not the case, then it processes the response. Then we also have a catch exception here that checks the amount of retries.
Yeah.
And if there's an error, it also retries it. So the problem with this is that it has it's retrying at a specific amount of intervals, and you really don't have control over things like jitters, like I explained earlier.
Yeah.
You don't have control over introducing a circuit breaker. So this code, even if it does some retry, it's not scalable. It won't be able to scale. So what Poly does is that it introduces all these concepts, makes it automated. They've done a lot of work on it, and it's very, very scalable. So I'm going to go ahead and then show how Poly can be used.
All right.
So here we have an implementation that uses Poly. And I'm just going to explain each of the extension methods here.
Can I see how the NuGet package?
Yeah, so so these are the NuGet packages used. I'm just quickly going to show you.
All right.
So yeah, so this one here, Poly, that's the core of it. So it has some methods in it, but we usually don't use it alone. We use it in combination with this poly.contrib.wait and retry.
Okay.
So what this one does is that it has extra extension methods to configure basically what it says, waiting and then retrying. Yes. Okay. Then we have this one, which still makes it easier and then abstracts it out. So rather than having all your code in your HTTP client, you can just put it in your application configurations, and it just works without doing that. So I'm going to show you how that will be used.
Okay.
So let's look at the HTTP client handler. So here we have the HTTP client factory that creates the client like we've seen before.
Yeah.
And then we have the policy. This policy basically defines what kind of errors should be handled, the retrying, and
the response message.
Response message. So yeah. So we have this. We say you should handle it when it has a HTTP request exception, or when the result is this. So if you have an internal server error or the status code is timeout, then this policy should execute.
Yeah.
And then this wait and retry, it comes from the wait and retry NuGet package that we just looked at.
Yeah. From the Poly?
Yes, from Poly.
Yeah.
So here we have the correlated jitter backup. So this is the jitter I talked about.
Yeah.
And what this does is that it starts from 1, and then 5 is the maximum amount of retries. So between...
You set that, right?
Yes, you set it.
Okay.
So between when it starts and the maximum amount of retries, it randomizes the interval of retries. And
so now the jitter works with Poly?
Yes, it does.
Okay.
Yeah. So you can see it being used here. We have the retry policy, then we execute it, and we just pass in our HTTP client with the request.
Wow.
Now, I know I talked about the the extension method that's in this NuGet package here.
The HTTP extension?
Yes, okay. Microsoft extensions HTTP.poly. Yeah. So this one now provides a very clean way of even doing this.
Okay.
Yes. So I'm going to show you in a minute.
All right.
So I'm just going to put some code in the program.cs.
Okay. Have you started that already?
No, not yet. Just a minute. So in our program.cs, we can define this retry policy. We can define different policies.
Okay.
So we've defined this retry policy, and if we can see, we just say HTTP policy extensions, handle transient HTTP error. This just means that handle when there's a HTTP request exception error. Then this defines the wait and retry, just like we saw in the other way.
Yeah.
And then this introduces circuit breaker. So it says handled events allowed before breaking. That means how many times should it process the request before it breaks the circuit if there are errors. And then the duration of break, that's how long should the duration stay before it retries.
So where did you define this?
Yeah, so this is duration of break here, times pound dot from minutes. That's the how many minutes it should wait.
Oh, okay. So I can say that now.
Yes, yeah. Yes. So, and then once you do that, all you have to do is to just add, sorry.
All right.
So all you have to do is to just add this, add policy handler, then you have this your retry policy, add another policy handler, this. So you don't even have to do anything here anymore. With that in our startup, we can easily just remove everything here. We don't need it anymore.
Okay.
It just makes our code cleaner. And we remove this. And that just works that way.
Wow. Which is better.
Mm-hmm.
Instead of having like 100 lines of code, you have 50.
Yes. So, you know, in just a simple way like this, you see how we've converted our code here with a lot of logic, with different, and which we don't even scale. We've converted it to this, which just contains our HTTP request, and it still scales because it has all the configurations for resilience.
Yeah. So aside this poly configuration, is there any other way to make our microservice resilient?
Yeah, so there are other ways that you could make your microservice resilient. So for example, let's say you have an application that reads from a queue and supposed to process the messages from that queue. We have what we call dead letter queues, where messages that fail are put into the dead letter queues. So rather than have a message continue to be retried or being processed or is failing and then we're having errors in the application, it just pushes it into the dead letter queue. So we can go into it, we can look at the message, we can debug and see why it failed, and then we can now retry it. So that just makes our microservice more resilient as well.
Okay. Actually, I thought aside this resilient, aside this configuration, actually, I thought we need to like look into how this services are splitted and how they all work together in one application. I don't know if you get me.
Yeah.
Do you get me?
So in what sense?
In what sense? Okay. Let's say for instance, I have a banking app. Now, in my banking app, I have transactions and other things. Then I have to log in first.
Yeah.
Now, in my code, I will definitely have authentication service. That's for the login and all that. Then, let's say I have transaction service also. Now, these are different different services, and I have different database for them. So, how can I connect them together to make it work. I mean, when you log in, then you have access to another, then you have access to another. Is it?
Yes,
can we relate that to this?
Yeah, so that's basically how each microservice are communicating with each other.
Exactly.
Yeah, so we could have a queue system. So there are different ways microservices could actually communicate with each other.
Okay.
It could be synchronous and it could be asynchronous.
Okay.
So in the synchronous way, each service is just making a HTTP call to another service.
Okay.
And then they get a response immediately.
Oh.
But in an asynchronous way, you can push to a queue and then maybe like RabbitMQ or Kafka or whatever messaging system you are using. Okay. And then the other services would read from that queue and then process. And maybe in a situation where you don't really need to get real-time updates. So let's use Instagram, for example.
Okay.
You gain a new follower. It may not be very important that immediately the person follows you, you see it. You know, it's permissible if you see it like 10 seconds later or a minute later.
Yeah.
So in situations like that where eventual consistency is permissible, then you could use an asynchronous method for that.
Wow. Thank you. So is there any advice or anything you would like to tell our audience concerning the topic?
Yeah, so what I would just like to say is when building an application, you know, there's a lot of rave about microservices today. And it's not, you don't just jump into it and then use microservices because everybody's talking about it. What you could do is sit down, analyze your application, see if it will be beneficial, analyze your cost and your benefits. And then if it's beneficial, only when would you go and use microservices. But if not, then just stick to monolithic application because it's less costly, it's less stressful. Yeah, you don't use so many resources. If it's a small team, that might be a better option for you. But if it's a large team dealing with a larger application, then microservices might be the option for you.
Right. Thank you so much. It's good to have you on the show. Thank you for coming. Choosing the right architecture for your application, it's crucial. But understanding how to implement it is very important. I believe what you've learned from our guest today, Chukwuma, will help you to make further decisions when choosing which architecture to use for your application. If you have any question concerning this topic, you can reach out to our guests on his socials. Don't forget to subscribe, like, share with your friends. Until I come your way next time, I remain your girl, Chazi. Bye.